this video, we are going to take a look at JWT, also called as JSON Web Token. This is an introductory video which covers the basics of JWT along with its structure. JWT stands for JSON Web Token. So whenever you would like to have information to be passed from the service or the server to the client, so client in the sense the consumer, you can always make use of JSON Web Token to send that information in a secured manner. So for example, if you would like to have some kind of authentication to be performed at the server and then the server wants to return some kind of secured information to the client, then you can use JWT. Not only that, whenever you would like to have any other subsequent requests to be made from the client to the server, you don't really need to authenticate every time, but instead you can just use the same token over and over again in order to use the same authentication mechanism whatever the server did earlier. So which means you just authenticate for the first time and the server generates the token and returns it to the client, and then onwards the client simply uses the same token to get it authenticated or authorized for all the subsequent requests. So usually it happens between two parties, that is server and the client, or the service and the consumer. So JWT, which is nothing but the web token, contains all the information necessary for our consumption. So which means whenever you would like to have the username or all the roles, email and all of that stuff related to the security, all that information is made available in the form of JSON. So you can see it is an object of type JSON on its own, so which means all the information related to the security can be passed in one single token. And again, it is not compulsory, it is not mandatory to have all the information to be sent, but if any information needs to be sent across the wire, you can still make use of JSON Web Token. But care should be taken in such a way that you don't really send any kind of passwords here. So this is not 100% secured. It is like you are sharing the information and authentic information from the service to the client. So everyone can still see the information what is available as part of the token. Everyone can see the information which is available as part of the token. So token here contains all the information which can be seen by everyone. However, whenever you would like to have that particular information what everyone can see also to be encrypted, you can still make use of it. So it doesn't mean that everyone can see always everything, but still you can make use of your own encryption and decryption methodologies to have that particular token and all its content to be made much more secure. It is mainly used in web applications. As I mentioned, whenever you are having any REST-based services and if you'd like to have the consumers to actually have some kind of authentication against REST API, you can make use of that. So most of the time, this JSON Web Token will be made useful, especially in web applications or services. And while I mentioned it is web applications or services, you can literally use any kind of technology in order to work with JWT. So you can use JavaScript, Node.js, Java, .NET or any of those particular languages or platforms to work with JWT, as because it is an open standard. So whenever you are working with JSON Web Token, you can pass that particular web token for all the subsequent client requests using URL in the form of a query string or a body parameter just like a form post, or you can also send it using HTTP header, usually with the header the header entry name is X access token. So you can use either of these three, any of these three. So you can send it in the form of query string, you can send it in the form of body parameter using form post, or you can also use cookie or HTTP header to have all of that particular information to be passed to the server. So the next thing is that this is mainly used for single sign-on contact. So which means imagine you have multiple websites and you would like to have the same kind of token to be used across multiple websites. You can really make use of that in a very simplest fashion available. So you can have the authentication to be made at one website and use the same token against other website and have the same web token to be reused in multiple other websites, and all of those websites can share the same kind of token available, and thus you can get the single sign-on to be working very easily. So let us quickly look at the JWT structure. First of all, the JWT or JSON Web Token is separated with dots and it is having three sections. So which means I have the first section, second section and the third section. All the three are separated using dots. So whenever you see any kind of JSON Web Token, you are going to see essentially three parts and each of those parts are separated with dots. Next, those particular dots, even though they separate those sections, each of those sections are named on their own. For example, the first section is called header, the second section is called payload, the third section is called signature. So each of those sections have their own significance. So, and the most important thing we need to understand here is that all of the sections like this information, the second and the third, like header, payload and the signature, all of those three are base64 encoded. So I just wanted to stress here, it is just only encoded, it is not encrypted. So which means any kind of information which has been encoded can be still be decoded very easily online or just using your own particular application. So there is no key involved and there is no encryption involved here. So this is not a secret. Base64 is just only a standard to make sure that the data is available in certain format. So this is not an encryption, this is just only encoding where everyone can still deal with it and decode it very easily online. So the next thing is that header. So the first section, whatever we would like to discuss here as part of the three parts, is the header. So the header is usually a JSON object which contains at least two parts. So I just wanted to go with only two parts. It can also have other things, but usually any kind of JSON Web Token will have a header which essentially has at least two entries. The first one is type, which means what type of data it is representing. In this case it is JSON Web Token and it has to be made available. So type is JWT always. The second one is algorithm. So whatever the hashing algorithm you would like to use in order to get it hashed, you can mention that. So you can provide HS256 like HMAC SHA 256 or RS512 or EAS or whatever. We have a bunch of those, and you can use any of those particular hashing algorithms in order to have that respective web token to be encrypted and signed and also hashed. So that is nothing but the hashing algorithm. So you need to define the algorithm under which this particular entire token is being hashed. So that needs to be specified right inside the header itself using this particular entry called ALG algorithm, which stands for hashing algorithm. Now that we understood something about the header, let us jump to payload. So this is the information which contains all the necessary data which needs to be sent across from the server to the client or client to the server. So which means all of the information, which includes the username, the roles, all of that stuff, email, first last name for example, all of that stuff can be made available as part of payload. So usually this is the information which will be used by the respective application in order to have certain UI elements to be made available based on the authorization it might have. Like, if it is admin, I would like to have certain UI elements to be shown. If it is not admin, I do not want to have certain elements to be shown. So This payload can also be called as claims. So claims means essentially those are nothing but key value pairs where each and every key, whatever you can see in the list here, ISS, SUB or whatever, those are all the default keys which are made available as part of the JWT standard. However, you are not limited to those. You can add your own keys in whatever the way you want it, but we'll have to ensure that those are not conflicting with the existing ones. So in this case, ISS stands for issuer. So which service app is actually issuing this token? Similarly, any subject, audience or expiration time, not before certain date, issued at what time or date, and if you wanted to provide any kind of ID, you can also provide using JTI and all of that stuff. And you can see I provided name and admin, which are not available here because name and admin are custom claims for which I added on my for myself exclusively to share more information about my particular security to the respective client. So you can add as much of information as possible here, and again you can see this is nothing but a JSON representation. So all of this information payload will be sent to the client as because you are sending the whole token which includes the payload. But again we will have to ensure that both header and the payload and the signature, all of these three are base 64 encoded. So which means entire information of header and entire information of payload can be seen by everyone unless you really encrypt the stuff inside the payload. So your care should be taken, like whatever the payload you are going to send is still visible to everyone, but no one can alter it. So if anyone changes something like admin to true, and if the client verifies that particular token, it is going to be returning as invalid. So the authenticity and the validation is always ensured that those are in sync. However, this information is always made public as because you can see it is base 64. So this is pretty important. This information cannot be modified as long as it is being verified by the client. If this information is modified and tampered with, then this particular whole token becomes invalid. But if no one is tampering this, everyone can see this information as long as they are able to decode it using base 64, which can be easily done by any online utility. So make sure that whatever the information you put in here is available publicly. And the next one is the signature. So signature is the third part and the last part. This essentially is the main and the heart of that particular token which encrypts this whole thing, and essentially it hashes it. So which means like this signature is essentially nothing but the base 64 of header and base 64 of payload together. You can see that I'm actually having a variable called S, which essentially nothing but gets the header encoded in the form of 64, payload also encoded. You can see I'm having a dot in between. So concatenate the base 64 encoded of header with dot and further with payload, which is also in the form of base 64. And once I get that particular string, you can see I am currently using HMAC SHA-256 algorithm to hash this string using whatever the password you'd like to provide. You can provide any password here, and the result of that particular hash is nothing but the signature. So this signature is nothing but the hashed result of this entire part along with your own password, whatever you are going to provide. So that signature, as it is hashed, it is only one way and it can never be decrypted in general. And further, how is JWT formed? The web token is nothing but header plus payload plus signature, and you can see S, which is nothing but I already have the header and the payload together with the signature. You can see whatever the signature I have received, that is further converted to base 64 encoding, and then the result is nothing but the JWT. So JWT essentially is nothing but the concatenation of base 64 encoding of header plus payload plus signature, which is nothing but the hash of the first two. So in that way I get the JWT altogether. So if anyone tampers with any of these two information, then whatever the information they have tampered will never be compared, will never be the same as whatever you put in signature. So in that way the signature already includes the hash of these two. So if anyone tampers this, then the signature along with that tampered message will never match and the token becomes invalid. So whatever the information is available in header plus payload is always made available to the signature in the form of a hash. So whenever you verify it, you have to ensure that the latest whatever you have received in the form of header plus payload should always be tested against the signature, and as long as they are both matched, the token is valid. If they are not matched, the token is invalid. So let us see on how this JWT in real world is being used. So imagine I have a client and a server. So whenever I say client, it is nothing but a consumer or a simple application which gets in touch with a server or a service application. So this could be a REST service or a web application or web service or whatever you would like to mention it as. But ultimately the information is going to be passed from the service to the client or client to the service. So the first thing is that the client or the consumer is going to request a token from the server. So which means the client needs to authenticate itself to the service. So whenever it needs to authenticate to the service, like it is the genuine class or genuine consumer to the service, it needs to pass the respective authentication credentials. So it could pass the username or password during the first request, and that request is essentially to request a token. So whenever the client is trying to request that token from the server, it needs to pass the authentication credentials. So the first step is requesting for a token by sending all the authentication credentials to the server or the service. And now the second step. So the token request has been passed to the server, and now the server is going to check the credentials against the database or whatever the source of security it is trying to authenticate itself. And once the credentials are valid, it is going to create a token that is nothing but the JWT, which includes the header, all the necessary security information which needs to be sent back to the client will be made available as part of payload, and the signature, all of that will be created by the server, and that is going to be the second step. And once the JWT has been created at the server, it will be sent to the client, and that will be received by the client here. So for some reason, if the credentials are wrong, instead of sending the JWT, it can actually send an error message to the client saying that it is not authenticated based on the information the client has passed. So you can see the first step, it requests for the token. The second step, this one validates the credentials, creates the JWT, and sends the JWT only to the client or the consumer. And now the fourth step is at the client right here. So once this client receives that particular JWT, it can verify the JWT to ensure that it is authenticated and at the same time it is not tampered with. Why? Because during this communication, right, whenever you receive the JWT from the service to the client, if some hacker comes in and that particular hacker tampers the data right here, you will have some false information. So it is up to you whether you'd like to verify the token about its authenticity and the tampered nature. You'd like to check all of that stuff. It is better if you can verify the token at the client also, but again, it is optional and not everyone does. So imagine you verified it and the token is valid, then you can extract the information from that particular token at the client, say username, and all the rules and everything will be made available to the client or consumer, and you can extract that whole information and make use of that information directly inside your application itself. And on top of it, the next one and the most important thing is that you need to persist that token at client side. So whatever the token you have received at the client side needs to be persisted or saved or stored somewhere at the client premises. If it is not stored, next time whenever you communicate with server, again you need to send the authentication credentials in order to get yourself authenticated. So in order to get rid of that tedious job of always sending authentication credentials, which also will have an effect towards performance, it is always recommended to have the token to be stored at client side so that you can reuse the same token again and again whenever you are having subsequent requests to the servers. So after 4, you can see there is one more request to the service for more information of something else, like I would like to have list of employees or list of products or list of orders. So whenever that request is being passed to the service, you can see I am actually using the same persisted token. So I did not send authentication details right now. I'm not going to send authentication credentials every time. This first step is only for the first time. You send the authentication credentials only for the first time. Once you receive the token, you process the token at the client side, and now you use the same token over and over again for all the subsequent calls to the server. And once you are requesting for more information in some other endpoint at the service, still you are sending the same token, and now it is going to be the server's responsibility to verify that whatever the token the client has sent to the service is valid. So this is essential. Even though you do not do that at the client side, the verification of that particular JWT, it is essential at the server to ensure that whatever the client is sending to the service, that particular JWT is always authentic and valid. So for that purpose, for each and every request the client is requesting to the service needs to have that particular JWT to be always verified against its validity. And once it has been verified, then it is going to send all the information what the client is asking for. Again, if and only if it is valid token. So this is important. For all of the subsequent requests from the client to the server is going to verify the JWT for every request it is receiving. If the verification has been passed with all the valid information, then only it is going to respond with whatever the information the client is requesting for. So this is essentially how the JWT really works inside a real world. So only for the first time during the first request it tries to authenticate itself and retrieves the JWT. And from then onwards the same JWT will be used for all the subsequent requests to the service. And the server or the service has got the capability to essentially say that this particular token can expire certain day or certain hour, or it is not valid before some date or whatever. All that happens as part of JWT configuration, and that information will be made available as part of the payload itself. So you can still expire all of the tokens, whatever are not necessary according to your business. Okay, so now that we understood something about JWT, let us see on how we can create JWT and verify JWT, try to tamper with the JWT and check the validity of the JWT. And I'm going to demonstrate all of this without really going through the real world coding, but I try to use the existing tools which are already available online for creation, verification, and all of that stuff. So I'm not going to create any kind of JWT using code here, but my upcoming videos will actually teach you on how to create, verify JWTs using JavaScript or C# and so on. But for now, as this is an introductory video, I do not really want to go into the coding, but let us just test it using online tools. So let us see on how to create JWT. You can essentially use the JWT directly from, test the creation of JWT using this link, or you can also use the others. So let us try to use the first link I have in here. So I go in here and select this one. Okay, so there you go. So you can see essentially these are nothing but the payload related attributes. Like I have the issued, expiration, audience, subject, etc. So in my case, I do not want to really go for everything. I just wanted to say ABC service application. I'm not going to provide issued at expiration of my token. I do not want to provide this audience and the subject. I do not want to provide any of that information. So you can see those are nothing but the claims or the payload. So once that is done, if you'd like to provide additional claims which are nothing but the custom claims, so in this case I would like to say username and I would like to say Jag, and if you'd like to have any other role information, something like admin, he's not an admin, so all that information you can send it. So these are all the custom claim types. You can provide as many as possible here, and you can provide all the values necessary. And you can see this is the claim set, or say the payload JSON object. So based on the information you have provided at the top, like ABC service app, username Jag, admin false. So this is nothing but the payload information JSON object. So this information will be passed to our service, which essentially tries to generate JWT out of it. And at this moment you can see there is no header information here, but essentially it is treated as something like HS256, or you can use any of this one. So currently let us consider I would like to use HS256 here, and header information, as you know from my previous thing, if you go back here, this header information essentially needs to have the type, which is always hard-coded to JWT, and the algorithm HS256. Those entries are already made available right here. Now that you have everything, like you have the payload and the header, which is already hard-coded to JWT, and the algorithm you have selected to HS256. Now for the signature you need to provide the password or the secret key. So in this case I would like to just say password 1. You can just provide whatever you would like to provide here and click on create signed JWT. And now you can see I have three parts. The first one is nothing but the header, and the second one is nothing but the payload information I might have provided, and you can see it has to end with dot somewhere, so you can see it has going to end here. And the third one is the signature. So you have all the three parts. So let us verify this and ensure that it is exactly the JWT we are going to send to client. So we have created the JWT, and now we are going to verify that. So to verify it, this is the link you can use, that is jwt.io, which is easier. So I can say jwt.io. So let us come down. Now you can see, first of all, let us make sure that it is HS256. Remove everything whatever you have in here. Paste our generated code, generated JWT, and now the moment you pasted it, you can see it actually decoded the header information from here. So this has been decoded into this, and this information is decoded into this. So now you can see this is the decoded payload. This is exactly what you see in here, and all of this happened, but it could not verify the signature. As I mentioned, header and the payload, everyone can see those two. But in order to ensure that it is a valid JSON or say valid JWT, you need to have the signature to be verified. So in order to have the verification to be done, you need to have that particular HMAC SHA-256 algorithm to be applied against whatever the password you mentioned earlier. So in this case, you can see I used password 1. So the moment you provide password 1, you can see it has automatically given signature verified. So if I remove some password information here or mistype it, you can see it is automatically giving back invalid signature. So I provide this one back. So let us consider someone is tampering this a bit. So which means, imagine a hacker wanted to provide admin to true. So for that purpose, imagine this is already decoded, so I can just copy this and I go to the other one what I mentioned as base 64 decode. So if I go to base 64 decode here, so I can provide this information and press decode, and now you can see I have every information whatever the JWT token has provided, and I can see ABC service app and all of that stuff, and admin also to false. So let me copy this, and now I go to encode, I click on that and I provide this, but instead of false I wanted to say true and click encode, and imagine this is the encoded information I received. So I just copy this and paste this particular new thing whatever I received, and now you can see header is same and the payload information, you can see I have everything except admin is automatically gone with true. But if you see the signature, it is invalid. So this is pretty important. So even though someone tampered your particular JWT, the JWT validation itself is invalid, as because that particular signature what is included here, this signature could not be in sync with this one. So while this particular signature is made with the previous one, this signature currently could not sync or validate against the information whatever is available right here. So in that way it is actually giving the problem. So now let us consider again, I would like to mention this one as false and click encode, and I get something different. Now I just copy this, go back here, so I go in here and click Control V, and now you should see admin as false. And if you come down, okay, there is some issue here, so let me, okay, there is some issue with respect to what is a spacing or whatever, but usually it should be the same. So for example, if I go in here, you can see there is a bit of difference here, like IN0 or whatever. So there is some equal to, so let me try removing this and see how it works. Except equal to, let me see if that works. Yeah, there you go. So equal to is something extra it has defined and we don't need that. So you can say signature has been verified. So this is pretty important. So even though everyone can see the information, no one can tamper with that. So once they tamper it, that particular signature is going to be invalid, and if the signature is invalid, then the whole JWT becomes invalid. But if you are really worried about the information which is going to be shown to everyone just because it is base 64 encoded, you really need to have all of this information to be really encrypted with your own public and private keys, and share the same private keys or the respective keys with the client or the consumer, and they can decrypt from their perspective. So this is pretty much about JWT. So in my coming up videos, we are going to see on how to create JWT using JavaScript, C# and other languages if possible.